Welcome back to the binary adder. I didn't get to finish it last night. And actually, I was thinking about it, it's going to be a little bit more complicated anyway because I've got to. Well, it won't be much more complicated. Just get this sorted and then. It's funny, last night I felt super accomplished having this done. But in reality, it's probably trash, isn't it? I mean, I haven't thought of a better way of doing this yet, but there's probably a much better way of doing what I want to do. That being said, I am going to push forwards with it until I think of something better. It's kind of the thing, is that I get a lot of bad ideas with this computer. But the ideas I'm having may be bad, but they are working and functional, so. Just super inefficient or whatever. Yes, that's fine. Yeah, right. You have to forgive me if I'm not thinking straight again this evening. I spent an hour in the sea earlier, so I'm quite fatigued. Although, in fairness, an hour isn't that long for me, but long enough to compromise my thinking. I'm not someone who gets smarter with exercise. Yeah, you know, don't know a lot to work with initially anyway, so it's yeah, anyway, right. So needs the input signal here, and for now that's just going to be a lever. This lever will be replaced with an address controller eventually, but she'll be replaced with we're replaced with an address controller combined with like a read-write input bit. But yes, for now it's just a lever. Now I want Have I been an idiot again? God damn it, I've been an idiot. I forgot to copy and paste the top layer of redstone. So, yes. So this one needs to come here, go there, but then you need this to connect like that. That should work. Let's just check. So again, the point of this device is to be able to count the number of times this switch has been flipped on and off. So, flip it on, that turns the bottom layer on, right? See that bottom one activated, middle one is off, top one is off. Blast, top one's on. Okay. I think I remember why. I am just being a little stupid. But I sort of remember why. No, I do not remember why. That shouldn't be on. So turning it off should turn the middle one on. And then turning it on should turn the top one on. Turning it off should turn all of them off. Yes. But turning this one on should not turn the top one on. And this time it works for whatever reason. I don't know why it wasn't working that first time. Middle one on. So basically it records every time there's an event in that switch. And what I want is for any time there is so if either of these two, the top layer or the middle layer, are on, I want the whole thing to be off. So what I want to do is build out like this. Blue is essentially my standard colour for memory buses, and I'm using red and green to denote leading, trailing and leading bits. Red is for trailing and green is for leading. basically there's going to be input from a read-write line over here, and that's going to be switching on or off read and write functionality here based on whether or not that's full or not. So in fact, this for now, this is going to come around here, and it's going to connect with that. What that should now mean is that this is ready to see how this isn't switched off, which means that this is the read bit here, so this is switched off because it's set to write. This is the write bit here, which is switched on, and this here. So it doesn't actually matter right now because they're all 0 anyway, but just need to add a repeater here. This is essentially the junction. This stops these buses being used and sends it off into this bus here. Although I think really you don't actually need these at all. I could just completely get rid of this and it wouldn't matter because it's essentially redundant if it's sending data down that bus or not whilst this is being written to. But why is this not getting up? It's not nearly, needs a repeater there. No, apparently that's still not enough. It's a little bit odd because these are very carefully tuned to be just fine. Like, why isn't this what? Oh, I see why this isn't working. Because the copy and paste process is chopped off the edge there. Essentially put a little redstone relay station in the middle here. Now you can see that's been written, that's a 0 written there. Now I need to fix this redstone too. Oh, that's actually really bad, it's had all of them chopped off. Okay, so that's 0, that's 0, that's 0, that's 0. Scream if you see one in the middle there that's red. I don't hear you screaming. See how far this is propagating. Somewhat less than nominal. So that's going this way. Oh, for God's sake. So just to make sure there's no repeating loops there, just turn this off. Sometimes with those redstone towers, if you're not careful, the repeaters get into a little loop with themselves. Which I suppose could be... no, it's not. Right, so that's functional. That looks like it should be functional. Right, so I've written zeros to that. Now I'm going to write 111 into the other one. So let's turn everything on. So these are currently all set to 0. I flipped that switch off. These are still set to 0. Yes. So when I switch this on, well, actually, it shouldn't really make much difference, but hang on a minute. Why is that? Why is this on? That's rather odd. Oh, it's because of that, isn't it? Right. So that has triggered that, and so I get inputs of 0 and 1. Yes. Which is interesting. This is going to be ugly as sin. Forgive me for what I'm about to do. Double repeater. This is bad design. Now it's necessary to have one. This is just ever so slightly too long for the signal to get there. It doesn't. So there has to be an extra repeater, but it's so ugly putting them in line with each other. Now there is a slight problem, which is I forgot to put in the read. So I forgot to set this here to read, so you can see it's currently turned off. The signal comes here and goes into this AND gate, basically. Rather crap AND gate. Well, this is logically this is an AND gate, right? And logically it's fairly optimal AND gate, but because this is one signal ANDed with all of these different signals, what I could have done is I could have just put a NOT gate on this one signal here, and then had a switch here, a single switch here instead, and that would have logically been an AND gate, but it would have been a more efficient AND gate. It would have got rid of essentially two of these redstone components. But when I first designed this memory stack was one of the first things I designed. As you can see, there's like hundreds of them over there. That's the RAM. So this is basically this is like me at peak stupid. Actually, this is not me at peak stupid. I had some very early designs that were significantly worse than that. But because this is a good design, right? It's just that logically I could have just put a NOT gate on this signal, and because it's reused across all of these ones, I could then have just got rid of these basically. Because essentially an AND gate is a switch combined with a NOT gate, or it's three NOT gates, or it's something like this. But again, one NOT gate on all of those, and then basically just the switch up here, and that would have logically been an AND gate, but with half the number of well, they're almost half the number. Obviously, you'd still need a couple of transistors for the NOT gate on this signal. But anyway, first thing I need to do is I need to fix this so that it's actually turned on. So now it's written to those, and yes. Now when I switch this again, that top one should turn off rather. Oh right, yes, I've created a loop. So what I can actually do is I can just do this. So obviously when I'm done, there'll be a secondary signal or receive that will trigger it to output its result, right? But for now, I just wanted to output the result when I'm testing, so that'll be signal from here. So run through that all again. So currently it's all off. Bottom one is on. So now it's going to add 16 to 16. And it is broken. Not sure why that's not on. Okay, so these ones are broken because... Hang on a second. Do I just need to get rid of these? So that still doesn't work. can do now is actually just do this. Basically, the way these things are is that they add signals together, so it's redstone signal strength affects it a little bit, basically. So that's why having a repeater here that's close to that causes it to break. This one at least is supposed to be off. This is going to look so sloppy because I'm just not paying attention at all to where I'm putting them. But I'm too tired to be exact. Well, maybe I'll straighten it up at the end. Okay, so having a repeater here is closer to that than that repeater is, so it overrides it. Because it sends you a signal strength comparator. This one is just broken entirely. Apparently I really wasn't paying attention yesterday. Hey, hey, hey. So they're all on except the bottom two. Why aren't the bottom two on? Well, the bottom one shouldn't be on because it's just 2 plus 2 is equal to 0, right? But the first one should be on. And hang on. Okay, so this is off, which is why it's off. Oh, right, okay, so that's broken there, that's why. Otherwise, this is correct. Right. Man, it looks cool, doesn't it? Right, let's try adding some more different numbers together. What am I going to put in? Let's switch off. I'm going to try adding. Just going to try adding 2 plus 2 should, yeah, 2 plus 2 equals 4. Let's do that. You know what it is, right? My brain is too complicated to do it. My brain is too tired doing oh, excuse me. My brain is too tired to do any complicated binary arithmetic right now. So like, I don't want to. I don't want to be doing 16-bit binary arithmetic on the stream. Let's do something simple. 2 plus 2 equals 4. Let's try it. So they should write it into it. So currently these are all written to with 1s. Yes. They should write 0s to everything except those 2. Rather, except to the bottom layer. Yes. Let me just explain. So obviously this is the right bit, as in writing, not left or right, but writing as in scribbling with a pen, and it tells it simultaneously turns on the inlet, so it lets this bit come in here, and also it overwrites the bit here. And obviously to store the bit, I'm just using this little arrangement here with a repeater and a comparator. The comparator there, it's purely to let it be turned off, right? So basically, the write bit comes up, opens the inlet, and overwrites whatever's written here. Whereas the read bit comes up, and basically, this is just an AND gate, so it just outputs whatever. Might as well re-explain that, since that was one of the first things I built, and the stream is now completely lost to time. Like 6 months ago. Yes, so that's the first one written. So this should now turn this off, and it goes to stage 2. Yes, and that's 4. So yes, 2 plus 2 equals 4. Perfect. Very satisfying. It's actually not slow at all either, is it? That was very quick. That was like less than a second, I think. And look at this thing, isn't it neat? So if you're just joining, this is my binary adder, which will be essentially, this is going to be a logic operation on the CPU, right? So this will correspond with one operator code. And what it is, that's memory over there. That's my RAM/hard disk, but really it'll function as both, or maybe more like a BIOS. But and then it's got, obviously that's the memory bus there, and the CPU is going to be built somewhere over there. And this is essentially, this is going to be a component of the CPU. Obviously, I'll copy and paste it to wherever it needs to go eventually. But what I've got here is I've got input data lane. So obviously it takes 2 16-bit numbers and adds them together to create a third 16-bit number that is the sum. So the first 16-bit number it receives goes into this registry here, this 16-bit memory address, basically. And then when it receives the second 16-bit, so second 16-bit number, that number comes along this bus here, and that also triggers this bus here to be turned on, and then it basically gets added together in here, which is the 16-bit binary adder. And I've layered it, so I've essentially layered it side by side. So this is essentially because I couldn't get the XOR gates into a 2D plane, or at least not spatially, not in a way that was super efficient. I mean, there is a way to do it, but it's not very efficient in terms of comparators and repeaters. What I did was I put it into a 3D plane, right, which meant I had to essentially stagger it into a zigzag like this to get it to fit. Otherwise, it would have been way up there, which would have made it very inconvenient for the buses and very unneat. Which is why the buses, like, essentially, there's one 2-bit adder here, and there's one 2-bit adder here, and then that's repeated all the way down, basically. But that's why it's got this weird sort of why one side's taller, for example, and then it's because I've stacked them next to each other. Otherwise, yes, it would be twice as high, and it would be very unwieldy. And then this over here is another 16-bit registry, which is where the result is stored, so that it can then be accessed later by another CPU, like a read command that will output the data to wherever. And this here controls the timing on which signal goes into this address and which signal gets sent down that bus. Okay, just give me a second.